Good morning, good afternoon, good evening, wherever you are. I'm Samir Mokashi. I'm Global Service Line Leader for Codes and Performance-Based Design. I'm normally in the Seattle office. Today I'm in Portland office, here to talk about mass timber and our innovative design and innovative solutions that we bring to our clients with Tom Jaleski. Tom.
So my name's Tom Jaleski. I'm director of the Portland region. I am an architect by trade, but have joined into the fascinating code realm.
So one of the things that you had the opportunity to work on is the Portland Airport. Give our viewers a little bit of a blend of why it is more than just an airport and why as an architect it fascinated you.
So the design team came to us and they wanted to bring the Portland Airport as an expression of the Pacific Northwest region. And to do that, since we have so many trees here, they wanted the airport to all be wood and then have the tree iconography with a supporting structure for that wood. So in doing that, we had to make a major change with the jurisdiction and show them how we can make this Type 1A building full of wood. And so then from there, we were able to piece and part through innovation, problem solving, thinking through it, working with the design team, using computer modeling, we're able to actually create the scenario where you'll be surprised, this airport is covered in wood, has exposed steel columns supporting it as a Type 1A building to create that feel and ambience, that welcoming feel of welcome to Portland, welcome to the Pacific Northwest.
I love that. You know, a lot of times people don't understand the emotion and passion we bring to creativity is not just a technical exercise for us. We care about the final product and how people feel walking through that as well. Tell me a little bit, what do you mean you added wood in the Type 1A building? Did you just compromise on safety? What'd you do?
No, so what they did is they wanted this large wood glulam structure supporting the roof because they were doubling the size of the main terminal area. And then they were going to infill all of that with wood pieces. So this would be across the entire expanse of the roof. So what we did from that base, from the floor, we looked at how high we could get and we created fire models at the highest floor and then basically covered the roof with thermocouples in the modeling to show that the wood would not get to the auto ignition temperature of the wood. And so through that demonstration, we're able to show the city that even though there may be a large sofa on fire, that the wood structure would not ignite, and therefore the equivalency to being a Type 1A building, being non-combustible steel or concrete roof, is met.
That is fascinating. And beyond that, what interested me in this project was you have steel column, and I've had architects come to me and can I fill my steel column with concrete and does it make it fireproof? And I said, no, it doesn't.
It does.
But in this instance, it does, because our engineers put on their creative hat and figured out a way to transfer heat internally to the column and using concrete for compression. And you guys blended that with a luggage fire from a train fire analysis. So you combine together a lot of different knowledge bases into one cohesive, simple answer. Tell me about it.
Right. So our computer modeling group did a great job. First we found a luggage fire that the London Underground had conducted. So basically it's one of those carts piled full of luggage, and they set it on fire as a real scale test, and then they measured it. So we used the data from that and then wrapped these large steel columns on all sides, completely surrounded it with these carts full of luggage, and then lit it on fire. And then just showed how it started to migrate. But we also covered the whole column with thermocouples and worked with the structural engineer that as the column face started to heat up, that we could show through finite element analysis that the heat was going into the core, into the grout, and then transferring and migrating vertically so that the structural integrity of that steel column was maintained even in a heated condition. so that the heat did not compromise that steel column. It was great to see all the colors and everything, and that was fantastic.
The concessions team also had some innovative and creative solutions that we developed.
Right, Samir. So then the concession stands, they wanted to also be all wood. Going with the theme of wood, they wanted to maintain that with the concession stands. So they had two different types. They had some that would be partially covered and some that would just be a lattice work, a wood lattice work that would be exposed to the roof above. So generally when you have situations like that, especially in wood that the city was already concerned about, you would want to have sprinklers and therefore solid roofs. The design team did not want the solid roofs. So we worked through, again, using computer modeling and understanding of the sprinklers at the high roof of how that would provide protection for any fire event that might occur in those concession stands, whether they be a retail situation in which gummy bears are by far the worst.
Really?
Gummy bears are a high fuel load. You'll be amazed. They're far worse than a restaurant. But those gummy bears we lit on fire, and we also tested and showed how that would possibly ignite the wood lattice work. The heavy timber the city was fine with. It was the lattice work that was their concern. But we showed how the heat would rise to the high roof, ignite those high sprinklers up there, and provide the protection that was required for them. So
that is awesome. You guys were cutting edge technology, innovative thinking, blending with the design. That's really nice to know.
And the finding those elements that really cause a worst case design scenario and being able to provide that to the city and the data on that, and the team that found that research and brought that to the fore was incredible. It was fun for me.
Yeah. And if you don't mind sharing, throwing out some names about people who worked with you on this. I know there was a few people who came in as junior engineers and grew up on this project, and other came in as a senior and added value. If you don't mind just...
Right. So Caitlin Holmes, thank you so much. You brought in so much in being able to do the fire modeling, to doing the research, to bring your innovation and your expertise to it was a great help. And I know her team, with Dion and some others that were part of that team, it was amazing what they brought together. Also Joshua Kleiber and the accessibility team. There were some innovation things with the new baggage handling system, the new way that they wanted to help serve clients, and for the different airlines had concerns. He was able to bring in those issues, talk about them, show that the liability of the airlines themselves was covered in how they were able to design their desk and manage the luggage. Was a great help as well. So thank you both. That was a great help.
And all of this happening while Code Unlimited was merging with Jensen Hughes. They didn't lose a beat and kept going. And we are so excited to be part of the Jensen Hughes team and looking forward to enjoying the ride and growing even more. Take care.
Thanks.